Okay, you guys, I'm going to do 3 problems from your quadratics with complex solutions worksheet. So before we correct it, are there any of you want to go over? Michaela? I can't hear you. We're gonna go over those in a little bit. We're gonna correct this one first. So you guys just get out the quadratics with complex solutions first, and then we'll go over the other one, the one where we had to know the ways of solving quadratic equations. We'll go over that one at the end. 13? Okay. 13, yeah, 13 looks like this. X squared plus 8x plus 97/6. You guys want to do this one because of the fraction, is that correct? What was that? 97. Oh, whoops. I said it right. Just didn't write it right. 97/6. So, what are A, B, and C? 1, 8, and 97/6. And then we've been figuring out the discriminant first, b squared minus 4ac. So what's b squared going to be? Because 8 squared is 64. Minus 4 times 1, which is still 4, times 97/6. If you put this in your calculator, go ahead and put it in your calculator. Negative 2/3. Yeah, you get negative 0.6 repeating, right? At the end, it rounds the last one up to 7. Well, what number is that? 2/3. And it was negative, so it's a negative 2/3. So we're just going to use negative 2/3 for our discriminant. Okay, so now we put it inside the quadratic formula. So negative b would be what? Negative 8 plus or minus the square root of negative 2/3, which is our discriminant, all over 2 times a, which is 2. Now, we could spend some time rationalizing the denominator because 3 is under the square root and is part of the denominator. But I don't want to spend time doing that right now. That's not what we're trying to learn in this lesson. So we are going to just write this as negative 8 plus or minus what? I. Yeah, anytime you're taking the square root of a negative number, you're going to have an I. All divided by 2. And that would suffice as the answer. Okay, number 9. Okay? Maybe not number 9. What number? Any others you guys would like to check to see if you got right or you couldn't figure out how to do? 23? Okay, 23, we're given 3x squared plus 5x plus 4 equals 0. And so we're going to find, wait, what number is this again? 23? Okay, we're going to find A, B, and C. What are they? 3, 5, and 4. Let's find the discriminant. B squared would be 25 minus 4 times 3 times 4. 48. And 25 minus 48 is? Negative 23 is our discriminant, right? So let's plug it into the quadratic formula. X equals negative b, which would be negative 5, plus or minus the square root of negative 23 all over 2a, which would be what? 6. Okay. But does 23 simplify? Square root of 23? No, but we can take care of the negative by doing what? We know that the square root of negative 1 is I, therefore we have I square root of 23. And there is our answer. Any questions on those? Do we get those? Do we need to do one more, or is that good? We can do 25. Let's see how you did on number 25. Here we go. 25. We have 2x squared plus 2x plus 5 equals 0. What's A, B, and C on this one? 2, 2, and 5. So we have b squared is minus 4 times A, which is 2, times C, which is 5, which is what? 40, which is going to give us a negative 36. Plug all this into the quadratic formula. X equals negative 2 plus or minus square root of negative 36 all over 4. Now, I got a lot of you guys asking me questions on this, and I remember the other day. 36. What do we know about 36? It's a perfect square. So what's the square root of 36? And we also have a negative, so we have a square root of negative 1, which is I. So we're just going to write it as negative 2 plus or minus what? 6i over 4. Yes, we can simplify that further, right? 2, 6, and 4 are all divisible by what? 2. So we can factor 2 out of the top and the bottom and cancel them out. So that's going to leave us with what? Negative 1. You guys got it. You guys sound like you got this down. All right. Okay, so negative 1 plus or minus 3i over 2. Okay, we're going to correct this assignment right now. Quickly. I want everybody to solve this one right here. Okay, I want everybody to do that problem right there. On the back side of this paper. Everybody turn it over and do this one on the back side of the paper. Okay, let's see which way you think is the best way to do it. Okay, all right. The best way to do this one is by getting x squared by itself. So we're going to add 24 to both sides, and we're going to get 4x squared, Noah, equals 24. And then we're going to divide by 4. Those are going to cancel out. We're going to get x squared equals 6, right? And then we're going to square root both sides. And we're going to get x equals plus or minus the square root of 6. 6 is not simplifiable, right? No perfect squares that go into it, so that's the answer. Got it? That's how you do one like that. Hey, when you guys, from now till you quit taking math someday, some of you guys are going to be engineers or scientists and stuff like that. Okay, some of you are going to take lots of math in college. You're going to be using the quadratic. You're going to see quadratics all the time. You got to learn how to recognize them and what's the best way to solve them. Got it? And it will make your math so much easier if you know how to do quadratics. I'm telling you. Calculus, when you guys take calculus your senior year, you're going to need to know how to solve them. If you know how to do them, you're going to be great. Okay, we are going to move on. Put that away. We'll turn this one in next time. Okay, today, I forgot to write the objective up on the whiteboard, you guys, but here's the objective. We are going to solve systems of equations that have a linear and a quadratic, or a linear and a circle. Okay? That's today's objective. Now, I believe, at least I asked my last class this, and most of them had. There had been a few of them that couldn't remember them. How many of you guys remember solving systems of equations? Not this type, but just systems of equations. How many remember that? Maybe this will jog your memory. The three methods you learned, and you guys solved systems when there's two linear equations. You guys would probably learn to solve them by graphing. Then you probably learned to solve them by substitution. And, whoops, substitution. And then you also learned elimination. And you probably had something that looked like 2x plus 5y equals 11, and maybe 3x plus 6y equals 12.
you might have had something like that. And you had to solve it in one of those ways. Now, if you solved it by graphing, what are you looking for when you're solving it by graphing? Okay, just a second, and then I'm going to answer. What are you looking for when you're solving something by system by graphing? No, you're not looking for slope. Well, think about it, you guys. A system of equations is, we want to know when both equations, if I want to know the x and the y coordinate will satisfy both equations at the same time. So we're looking for, say that, the intersection of the 2 points. So if you graphed it, you're looking, let's say this is your y-axis and your x-axis, and this is the two equations. You're looking for the point where they intersect, okay? Yep, like a traffic intersection. Okay, so that's what you're looking for. Okay, so do you want, just to remind you, would you guys like to solve this one really quick? Should we solve this one really quickly? What method would you like to solve this one by? I think elimination might be best on this one. If we times the top one by what? 3, and the bottom one by what? 2. -2. Why -2? Because you need one to be positive, one to be negative for them to cancel out, right? 3 times 2x is 6x. 3 times 5y is 15y. And 11 times 3 is 33. Okay, -2 times 3x is -6x. -2 times 6y is -12y. And -2 times 12 is a -24. If you now add those two equations together, 3y equals 9, right? Then you're going to divide by 3, and you're going to get y equals 3. So you got your y coordinate. How do you find the x coordinate? Yeah, it doesn't matter which of these two equations. Let's do the top one. It's a little smaller. So we have 2x plus 5 times 3 is 15 equals 11. We would minus 15 from both sides. And what would we get? -4. We divide by 2, and what do we get? -2. And so these two equations are going to intersect at the point -2, 3. If you were to solve each one of these for y, graph them in your calculator, you would see that they cross at -2, 3. Got it? Do you remember doing that now? How many of you have never, how many of you never remember doing anything like that? I need to know if you haven't. So you guys, did you do this last year or 2 years ago? Okay. Both years? Okay. Well, today, you guys, the difference is, what's the difference? The difference is one of your equations is going to be linear, and the other one's going to be a quadratic. So what's the, instead of having two lines, what are you going to have? A parabola and a line. Or linear and a circle. So a line and a circle, right? That's a good question. How many times what's the most number of times they can cross? Yeah, you can have a parabola and you can have a circle, a line crossing it twice. Can you have it cross more than twice? Could you have it intersect once? Yeah, if you had something like this and it touched right there. Can you have it? What? Straight through it? Yeah, you could do that too. Yeah, you could do that. Hey, that's Indiana's. IU, Indiana. Huh? They lost last night on a wood play. Okay. Or what's the other possibility? What's the other possibility here? Not intersecting at all, right? And there would be no solution to it. We got it? Okay, so we're going to do one right now. Here we go. We're going to solve this one first by graphing and then by substitution. JD. Oh, well, that's a good question. We could have one where it crosses through it twice, right? Well, okay, yeah, you bring up a good point. A circle is not a function. We're not going to be able to do these in our calculator. You're going to have to do them by hand. Okay, it can cross once, or it can cross not at all, right? So you might have 0 solutions, 1 solution, or 2 solutions to a circle and a line. Okay? So, yes. How can it cross only once? It's what we say tangent to the circle. It's like taking a ball and putting one of these yardsticks on top of the ball. It only touches it in one spot, right? That's what we call a tangent circle. A tangent to a circle. Okay, now. Okay, here we go. This one right here. Y equals x squared minus 5x minus 6, and y equals 2x plus 2. I would like everybody to go to your calculator. I want everybody to type in, or to go to y equals and clear everything out. I need you to hurry because we're not gonna stop. And then I need you to go to. I need everybody to have a standard window. How do you get a standard window? So hit zoom and hit 6, and that will give you everybody. So we're gonna all have the same window to start with. So we got that. Okay. Now hit your y equals again, and let's type in these two equations. X squared minus 5x minus 6. And also 2x plus 2. And hit graph. We've already got a standard window, so you can just hit graph. How many times are they intersecting? Okay, twice. How many do we see on the graph? Once. We can see that intersection point. But we know they intersect somewhere up here, don't we? How can we change our window so that we'll be able to see that? No. Hit window. Hit window, everybody. We just want to go up to see the intersection point. What would we change to go up? Y what? Max. Y max. So everybody go down to your Y max. Just change it to 20. I would also change your scale to 2. Change your scale to 2 just so it doesn't have so many tick marks. And graph it. Notice we don't see the vertex of the parabola, but we really don't need to for what we're looking for. Oh yeah, I did. Okay, now the calculator has a special feature to find intersection points. It's under the calculate menu. It's called calc on your calculator. Do you see it? Second trace. Everybody look above the trace says calc. So everybody hit second and trace. And which one do we think we want? Number 5. Now, it asks you for a first curve with a question mark. All you want to do, you only use the left and right arrow keys to move up and down or left and right. Because it will follow the path. You never use these up and down keys. That will just toggle back and forth between the two curves. Okay, so I'm going to use my left arrow key to get my cursor right about where they intersect. You can't get it right on. So don't worry about it if you don't get it right on. Okay, no problem. Okay, hit enter, and you get what? Okay, you get second curve. It's close enough. Hit enter again, and now it's asking for overall guess. You're close enough. Hit enter again, and where do they intersect? -1, 0. I wonder if we're doing something a little bit wrong. Okay, now hit second and trace again. Go to calc menu and get intersect again. And let's go do the next one. Now you have to hit the right key until you get clear over there. Because my graphing calculator is on the computer, it takes me a lot longer than you guys to get over there. There, does that answer your question why I have so many of those on there? Tyson? Now you know why I got so many on there. Okay, so hit enter. Second curve, hit enter. And enter again. 8, 18. Is that what you guys all got? That is how you would use your calculator to find the answer. Can you handle that?
You go like
JD.
above it, you just hold it right.
On the computer it won't do that. I have to tap it, but on the calculator you guys can do that. Okay? Yeah, believe me, I wish I could do that. But I have to tap it on the computer. Yes. Okay. So now I need to teach you guys how to do. Need to teach you an algebraic method. Now, last period when I taught, listen, you guys. Last period when I taught, I said we're going to do an algebraic method. When we got done class, I said, okay, now you got to do these by graphing and these by an algebraic method. And the students were looking at me like, what do you mean an algebraic method? Well, I mean substitution, okay? These won't work elimination. You can't do elimination on these because of the x squared. So you have to do a substitution. So that's what we're going to do right now. We're going to get these same two answers, but I'm going to show you how to do it with an algebraic method, okay? So here we go. What do you think? Using substitution. You guys know how to use substitution. In substitution, what do you do?
In for x.
You can solve for y and substitute in for your other y, right? So guess what? This is y, solve for y, and that's solve for y. So what can I do, Sam? Yeah, I can just write x squared minus 5x minus 6 equals 2x plus 2, can't I? You guys remember this? If C equals A and C equals B, then A equals B, right? Then A equals B. Well, that's all we did. Okay, think of y as C. A is this expression. B is this expression over there. And if C is equal to both A and B, then A and B are equal to each other, right? So I can set those equal to each other, and I can solve that. What kind of equation is that? It's quadratic. How can we tell? It's x squared, right? Now, what's the difference about this quadratic than the ones we've been looking at? Yeah, we don't have 0 on one side. Can we get 0 on one side? Yeah. Let's minus 2x from both sides. And let's minus 2 from both sides. And that will set this thing equal to 0. So what am I going to end up with? X squared minus 7x minus 8 equals 0, because those are all going to be 0. Do you guys all know how to solve that? You could use a quadratic formula, but there's an easier method. It's factoring. It's factorable, isn't it? Are there two numbers you can times together and get negative 8 and add together and get negative 7? What two numbers? What? 1 and negative 8. That's right. Well, look. Negative 8 times 1 is negative 8, and negative 8 plus 1 is negative 7, which is your middle term. You don't like thinking about what numbers work? All you have to do is look at all the factors of that last number and see which one works. Okay, x minus 8 equals 0, and x plus 1 equals 0. So x equals 8, and x equals negative 1. You got those two? You guys all got your answer? Now, is that what our answer was up here? That's the x numbers, right? Everybody look at this. The two numbers we got for our solution were the x numbers. How do we get the y numbers? Yeah, you substitute the x numbers in. Which equation? Either one. Which one's the easiest one? Yeah, I would substitute them in this one. It's definitely easier. Well, you got the x number. This is going to make either one of these equations true. We already know that. So all we have to do is substitute in one of the equations. We're going to choose that one because it's easier. Yeah, because I got an x number here and an x number there. Remember when we did it by graphing? If I put 1 in, if I put negative 1 in, I'll get 0. If I put 8 in, I'll get 18. Watch. Negative 1, 2 times negative 1 is, what's 2 times negative 1, you guys? Negative 2 plus 2 is 0. So there's your negative 1 comma 0, right? Now if I put 8 in, what's 2 times 8? 16 plus 2 is 18. There's your other answer. That's how you would do it by substitution. Can you guys handle that? Okay. Now, I need to show you how to do one where there's a circle and a linear equation. So we're going to do those. Okay, let's say I have this, x squared plus y squared equals, we're going to say 25. That's not one of the ones you guys have on there, is it? I need to show you this first. How many of you guys have ever graphed circles before by hand? Okay. There's an equation. Now, it's like JD was saying it first, or who's saying that? A circle is not a function, right? And because it doesn't pass the vertical line test. You guys remember that? So, but it's still a graph. It's still an equation. We can graph it. This is what we call the general form of the graph of a circle. X minus h squared plus y minus k squared equals r squared. Now, and when you do this, h comma k is equal to the center of the circle, and r equals the radius. Okay? So I want you to look at this equation right here. What do you think the center of the circle is on this one?
20. Yeah, 25.
Oh, the center of the circle. What's the x and y coordinate of the center of the circle?
Comma y.
No, but what are the actual numbers?
I don't know.
It's in this form right here, isn't it? Or maybe it'd help if I did this.
One.
Now, whoops. I didn't mean to put that k there. Okay, x minus 0 squared plus y minus 0 squared equals 5. Did you know that this is the same as the blue one right here? The red one I just wrote is the same as the blue one?
Oh, yeah, I did.
X minus 0 is just x, so you can write it as x squared. Y minus 0 is just y, so you can write it as y squared, right? And 5 squared is 25. Now, according to what I showed you up here, where's the center of the circle? 0, comma 0. Center is equal to 0, comma 0. And where's what's my radius of my circle? No. 5. R is the radius. R, 25 is what r squared is equal to. I just want to know r, which is the square root of 25, right? Everybody got that? So, we're going to graph this now. So everybody draw a precise graph. Trace and you are so full of wisdom sometimes. Okay. Now our center is at 0, comma 0 right here. Logan, you're struggling right now, aren't you? Trying to stay awake. Get out your pencil and write this. It will help you. Okay. 1, 2, 3, 4, 5. I don't blame you. If I was sitting down there and I was up here talking, I'd probably fall asleep too. Huh? It's all right. I'm not offended. I fall asleep all the time when I'm sitting in classrooms. All right. Huh? Hey, what are you saying?
Sam said I fall asleep all the time.
Sam said. So, You guys, now that I have my radius, notice I counted up. I have my center, 0, 0. I put 5 on each of, out here, each place, and I'm going to draw this circle, or kind of try.
No. No.
Okay? There's kind of our circle right there. Okay, now, I've got this line. Oh, I forgot to give you the lines. Here's the line.
It's going to be an egg.
Here's the line, you guys. Y equals x plus 3. You know what? Let's go x plus 3. Okay, well, what's the y-intercept of this line, you guys? 3. So 1, 2, 3. What is the slope of this line? So go up 1, over 1, about right there. Or down 1 to the left 1, down 1 to the left 1, down 1 to the left 1. And so we have this line that goes like this and like this. Well, if you were a guessing person, where would you guess that this intersection point is? 7. 7? Right out here? 2? 2, comma.
Where are you getting 7 from?
Yeah, 7 would be right up here. Well, I would say about 1.8, comma 4.8. That's my guess. 1.8, comma 4.8. What do you guys think?
Yeah, so I think like 4.9.
Well, it's not going to be exactly 2 and 5, because think about this, you guys. This circle is kind of curving down. You know that for sure it can't be 5. 5 is going to be the highest point on that circle. Okay, so you know it can't be 5. It's got to be a little under 5. It could be 2.
It's only 2 goes straight across.
Yeah, that's true. Okay, so it's somewhere in that area. Okay, now, if you're a guessing person, where would you say this one crosses? Negative 4.7, comma. That's my guess. I think my graph's a little bit off, though. Okay, should we see how close we are to estimating? Do you see why this method is not very good? We're not going to get a very exact answer, so we need to use an algebraic method. So here is our algebraic method. We got to write these two equations, x squared plus y squared equals 25, and y equals x plus 3. So here we go. X squared plus y squared equals 25, and y equals x plus 3. We're going to have to use a substitution method. Do you see something we can substitute? Y, what are we going to substitute for y? X plus 3. So we're going to take x plus 3, and we're going to substitute it in for y right there, and we're going to get x squared plus x plus 3 squared equals 25. What kind of equation is this? Quadratic. What we need to do is multiply everything out and get everything on one side. So here we go. X squared plus x plus 3 times x plus 3. What is that? X squared plus 6x plus 9. And I'm going to also minus 25 from both sides, so I get that. Now I got x squared plus x squared is 2x squared plus 6x. 9 minus 25 is what? Negative 16 equals 0. Well, which method do you want to use to solve this quadratic equation? Factoring or quadratic formula? I'm going to use quadratic formula. What's A, B, and C? 2, 6, and negative 16. Let me just show you. X plus 3 times x plus 3 is equal to x times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. Add the two 3x's together and you get 6x plus 9. Do you see that now? You guys see that? Okay? That's where you got the x squared plus 6s plus 9 right here. Okay? Do you understand where we got the 25 from? Negative 25? We minus the 25 over from the other side. 'Cause you got, anytime you solve a quadratic, you got to get it equal to 0. Yes, you do. I'm trying to give you a few minutes to work on it, so. Okay, so the discriminant is 164 because it's 36 minus 4 times 2 is 8 times 6, negative 16 is what again? 164. Anybody agree with that? Okay, so we're going to have x equals negative b, which would be what? Negative 6 plus or minus the square root of 164 all over 4. Okay. Hey, by the way, we need to know, we don't care to leave this in the terms of square root right now for this answer, do we? We want to find an x and y coordinate. So guess what we're going to do? Put this in your calculator. Everybody break out your calculator. Type in negative 6 plus the square root of 164. Negative 6 plus the square root of 164. Hit enter. Then hit divided by 4. 1.7? 1.7. Okay, now put in negative 6 minus the square root of 164 and hit enter, and then divided by 4. What do you get for that one? Negative 4.7. Now, I want you guys to look at this. 1.7, negative 4.7. Let's go back and see how close we were for our x coordinates that we estimated, Zach and Talon. How close were we? We guessed 1.8 and it was 1.7. And we guessed negative 4.7. We're right on there. Okay, some of you guys guessed that right on. Okay, so let's go back here. How are we going to figure out what the y values are? Negative 6 plus the square root of 164 divided by 4. And negative 6 minus 164 divided by 4, Tracy. Okay? 1.7 plus 3 is 4.7. And negative 4.7 plus 3 is negative 1.7, right? So they're like opposites, someone said. Okay, so let's check to see how close we were. We were pretty close, kind of. We're a little bit off on the second one. You get the idea? You ready for the assignment?
So do we have to estimate assignment before we actually?
Do you have to estimate on the assignment? No. Well, no. You guys, on the assignment, I'm not going to have you do both methods for each problem. I just did both methods for each problem to show you that there's 2 ways to do each problem. I'm going to give you 6 problems. You only have to do 1 method on each problem. But I give you, some of them I want you to do by graphing, some I want you to do by substitution. Okay?